Good morning, Statesman. We've got lesson 6.5, which is regarding indirect proof and triangle inequalities. Indirect proof is a fascinating method of proof, and it's going to be something we're going to do a little bit differently than what we've done. Still done with a two-column proof. But when we've done a two-column proof so far, we've started with a given piece of information and utilized that step by step to deduce our way to a conclusion with our statements, which is the what, and then our reasons, which is the why of an argument. Something to consider is the following, is it possible, logically, to prove that Mr. Granados is a bad teacher by proving that he is not a good teacher? It would, if the choices are binary, right? That we have that Mr. Granados is either good at being a teacher or bad at being a teacher, that there's no other possibilities. There's nothing in between, right? Wouldn't it be reasonable to say, and accurate to say, that if in the binary instance, if he is not good, then he is bad? And that's something that we're going to utilize from a reasoning standpoint to prove something that is by proving what it is not. So while that may sound confusing at first, I think we're going to get the hang of it as we attack this lecture. Let's go ahead and draw the following. Now, there's no other indication given about what types of lines these are. Sorry, that's the letter L. But we have lines M and N, right? And I'm going to number some angles. I'm going to have 1, 2, and 3, which are here. And here's what we're going to be given. What we're going to be given is that M is not parallel to N. So what we're going to use that to prove is that angle 1 is not congruent to angle 3. So what we're going to prove is the opposite case to be true. We're going to assume the opposite case to be true to make our point here. So effectively what we're trying to do is that what we have as our given is effectively going to be the opposite is what will be our proof step. So here's how we approach this problem. So we have our left and right statements and reasons, right? And what we're going to start with is the following, is we're going to take what we're trying to prove here, and we're going to assume the opposite case. So how we always attack these is that we're going to say that 1 is congruent to 3. And the reason why is that that's going to be our assumption. So we're going to say rather than given, we're going to say assume. Now, this methodology, where so far in our class, 100% of the time when we start a two-column proof, step 1 is restating the given. And the vast majority of you has so far demonstrated that capability on our proofs. Even if we've been completely lost on completing a proof on a quiz or a test, we've been able to complete that step, which is fine. I mean, some of you don't sometimes reiterate it exactly, which is all you really need to do, which is given. But here, for the sake of indirect proof, this is where we're going to have a little bit of a curveball. Instead, we're going to take this proof step, assume the opposite case, and we're going to work from there. So if 1 is congruent to 3, we make that assumption, then what we can make the conclusion is that 1 and 3 are corresponding angles, because that's just the definition of what they are. So if 1 and 3 are congruent corresponding angles, what that means is through that converse, that M would be parallel to N, because we would have two parallels, of course, cut by a transversal, which makes congruent corresponding angles. So what we've done effectively is shown a contradiction effectively, right? Is that, if 1 is congruent to 3, then m has to be parallel to n. Therefore, right, contrapositively, right, it's going to be that if m is not parallel to n, then 1 cannot be congruent to 3. All right? So proving what something is by proving what it is not. So let's take a look at something that's a little bit different now. This is an instance where I kind of chuckle at this because some of you guys are gonna, and I'm gonna use concrete numbers rather than using something that's abstract, because it's gonna confuse you guys otherwise, because there's the whole thing about A and B and C, but here's where we're gonna actually use some concrete numbers. So if we have 10 is equal to 6 plus 4, which it is. I mean, just that's plainly said. Then 10 is greater than 6, and 10 is greater than 4. Now, the way this appears in your textbook is that if A is equal to B plus C, then A is greater than B and A is greater than C. Or in other words, any sum is going to be greater than individual parts that are added to make up, to create it. Okay? So, seems logical. Let's go ahead and take a diagram here. So we have this diagram, and what we're going to try to figure out is which angle has the greatest measure. All right? So what's going to be the biggest angle that we have here? Now, we can't just go visually, right? Oh, this one looks like it's the biggest. That's not what we're after here. So let's figure out what we have given here. Well, we have what's marked as a right angle. So what that means is that angle 4 and 5 are perpendicular to each other. So what that means is when we have that perpendicular, that 4 is going to be 90 degrees, as well as 5, right? They're going to be congruent, as all right angles are congruent. All right, so what we know then is because we have a right triangle here. Remember we had the corollary regarding complements. So since 2 and 3 are the two acute angles that we have here, these guys are complementary. So the measure of angle 2 has to be less than 90. And the measure of angle 3 has to be less than 90. All right. Moreover, think about this. Think about the relationship that 1 has with 3 and 4. Gentlemen, this is the exterior angle theorem, right? So what we have is we have an exterior angle which is going to be equal to the sum of the two remote interiors. So what that means is the measure of angle 1 is going to be equal to the measure of angle 3 plus the measure of angle 4. Which means, right, go back to what we started with in the beginning. If 1 is the sum of 3 and 4, then 1's got to be greater than 3 and 4. All right? So, here we go. Measure of angle 1 is greater than angle 3. Measure of angle 1 is greater than angle 4. The measure of angle 1 has also have to be greater than the measure of angle 5, because think about this. What did we establish earlier? Well, 4 and 5 are the same exact measurement, right? And last but not least, the measure of angle 1 is going to be greater than the measure of angle 2. And why? Well, think about this. 2, as we established, is also less than 90. And if 5 is 90, then it has to be less than that. So what we've gone through is been proven here is that angle 1 is the greatest angle. Why? Because it's individually greater than every single one of those angles. Next. Let's discuss the angle side relationship. The angle side relationship says the following, is that we have the biggest side is opposite the largest angle, and the smallest side is opposite the smallest angle. And obviously that leaves one other angle left, which is the middle one is opposite the middle one, right, in terms of size. So it looks like this. So go ahead and construct here a triangle. Let's actually make that a little bit better. Let's make this guy not look like a right triangle, just because we don't want to have like a generic scalene triangle is what I'm trying to draw here. Here we go. Where we have A, B, and C. And then effectively what it's stating that is if we have AB, which is greater than BC. So think about what is opposite AB, right? Remember, that's going to be angle C. So what that means is that angle C is going to be greater than what's opposite BC directly, and that is angle A. All right. So let's make that a little bit more concrete, how that's going to look on your assignment, for example. And hopefully this is straightforward. You should probably be hoping for some test questions that look like this, because I think this is going to be pretty straightforward for you guys. So we're going to have A, B, and C again. Oops, get that off. So we have AB, which is 11. We have BC, which is 12, and we have AC, which is 13. And what we're gonna want to do here is we're gonna list the angles in order from least to greatest. Now think about this. We already know what the sides are, right? And for those of you who are still struggling to differentiate between sides and angles, we got to get that straightened out immediately. But here, what we have is the side that's least, right? We can agree upon is AB, I hope, because 11 is the smallest number. Well, what is opposite that? And that's going to be angle C. So that's the least angle. I have no idea how much that is yet, right? Maybe we have a way to solve exactly what that angle measurement is. But we just don't know how to do that yet. But what we can prove, though, here indirectly is that C has to be the smallest one because it's opposite here, the smallest side. We have BC, which is going to be 12. Okay, that's opposite angle A. And then we have AC, which is 13. It's the greatest one. And again, that's opposite angle B. So there we go. And of course, B would have to be the last one because it's the only option we have less there. So, last thing is regarding the triangle inequality theorem. And here's where we're going to try to differentiate and figure out what is the greatest sides and angles that we're working with here, or what are the possibilities of a side length. And this one, I usually like to show visually to you. And maybe if you're at home or you have readily available to you, there's a yardstick I have in class, and I also have a ruler, a 12-inch ruler. And yardstick being, let me write this out real quick. Inequality. The yardstick being 36 inches, 3 feet, and then the foot ruler, right, is going to be 12 inches. So 1 foot, or 3 feet and 1 foot. So the thing is, like, let's make an angle out of that, right? What we know is the following is if you guys put those two things side by side, and we were to do segment addition, 3 plus 1, right? 3 feet plus 1 foot. Visually look like this. But we're going to hinge, right? So let's swing this thing around and we make an obtuse angle. Well, we know that if we stretch this thing as far as possible, there's no way that we could connect the dots here with this side and this side with a 4-foot side. Because at 4 feet, we have the thing completely stretched out, and then we're just dealing with segment addition. So we know is that the sum of those two sides, so for example, if we were adding AB and BC, it has to be, those two sides have to be greater than what the third side is, right? That 3 plus the 1 has to be bigger than the 4. It can never be less than that, because you're going to have this overlap. We have AB, and AC, which are going to have to be, right, greater than BC. And then the third, all three of these are going to have to be true. There's not a single side that this is going to work out for, right? It's not going to be a possible triangle where we have AC plus BC has got to be greater than AB. Okay? So here's where we're going to prove what this triangle could be by proving what it is not. All right, here we go. So let's take a triangle, hypothetically speaking. This guy's 12, 20, this guy's 12, and this side is x. We're going to figure out the possible values of x. In order to do this, we need 3 inequality statements, okay? What we're going to have to say is that x plus 12 is going to be greater than 20. We also have to say that 12 plus 20 has got to be greater than x, and also that 20 plus x has got to be greater than 12. That's all 3 possibilities with the inequalities of each side. Setting it up the same way here, where all 3 possible sides, how do these guys set up as inequalities? You have to do all 3. This is what I require of you, all right? I understand that some of you are going to see a shortcut here, and that's regarding that one of these is going to be redundant. We're not going to use it, and you'll see that as we work these out. We're going to solve this, right? So if you solve the inequality, you know that if you're going to subtract 12 from both sides, you know x is going to be greater than 8. Or here, when we solve this guy, 12 plus 20, we have 32 is going to be greater than x. Or this last one, right, we're going to subtract 20 from both sides, where we're going to have x is going to be greater than negative 8. Now, right away, one of these just is an absolute ridiculous answer, right? Because we're going to say it's got to be greater than negative 8. Now, think about what's a possible solution. Things that are greater than 8, negative 8, like negative 7. How is that possible? How would you have a negative side? Okay, so we have to throw that answer out. That's a ridiculous one. So then now we have this combined inequality that we're going to write. And remember how we do this algebraically, writing in between 2 values. We're going to say 8, the least value, is less than x, is less than 32. Or in other words, x has to be between 8 and 32. It cannot be equal to 8. It cannot be equal to 32. At that point, right, we're going to have the side-by-side issue. Or think about it the other way. If you were to fold, you know, the yardstick and the ruler together, right? Now you have an overlap, and that doesn't make sense. So there's going to be a minimum length too. Okay. So last thing here. Let's figure out. I'm going to give you some side lengths here. 4, 9, 10, 8, 9. And 18, 5, 7, and 12. And we're going to figure out, are these even possible as triangles? Could these actually be side lengths for triangles? So we need to set up our inequalities. Do all 3 inequalities work? Is 4 plus 9 greater than 10? Yes, it is. 13 is greater than 10. Is 9 plus 10 greater than 4? Obviously, right? Both 9 and 10 are individually greater than 4, so the sum of them has to be greater, correct? And then, of course, we have 10 plus 4. Is that greater than 9, right? 10 is already greater than 9, so all those values check out. This is a possible triangle. Now, think about this. Take this guy right here. Is 8 plus 9 greater than 18? All right? This is false. So you know what? Because a single premise did not work, this is automatically not true. This is not a possible triangle at all. 8, 9, and 18, impossible. You don't have to go through all of them, right? Because like 9 plus 18 is greater than 8, but that doesn't matter, right? As soon as the first one doesn't work, none of it works. How about 5 plus 7 greater than 12? Hey, 5 plus 7 is equal to 12, not greater than it. So guys, this is also false. So just thinking about these things logically, what something is by proving what it is not. You have your assignment posted on Canvas. Good luck, Statesman.